Okay, in this video, I will go through section 1.4 of chapter 1, partial fraction, but with a specific type of partial fraction, which is with repeated root. Example 10 from the textbook. 11x squared plus 14x add 5 over x plus 1 squared times by 2x plus 1. Okay, so we've got x plus 1 squared, which means x plus 1 is the repeated root. Okay, this is a specific type of partial fraction which will be written in the form of a over x plus 1 plus b over x plus 1 squared. We cannot write down x plus 1 here. It should be x plus 1 squared. Because if it's x plus 1, it would be the same as this one, this x plus 1. Therefore, we wouldn't have to write down the second fraction. So therefore, the most important thing here in repeated root is if x plus 1 is a repeated root, we have to write down x plus 1 in the first factor, in first fraction, and then x plus 1 squared in second fraction. Plus, there is another root which is factor which is 2x plus 1. 2x plus 1. And let's write down c here. So therefore, we wrote down 11x squared plus 14x plus 5 over x plus 1 squared times 2x plus 1 as a over x plus 1 plus b over x plus 1 squared plus c over 2x plus 1. After this point, it is exactly the same as previous example in previous videos. Okay, all we need to do is, this is identical to a times, okay, we've got x plus 1, 1 of x plus 1 here, so all we need to do multiply a by x plus 1, not x plus 1 squared, because we've got 1 of this x plus 1 here. Imagine if this one was 3, this one was 9, because 3 squared is 9, so you wouldn't multiply this one by 9, a by 9, you would multiply a by 3, because there were 1 3 here. So therefore, a times x add 1, then multiply by 2x plus 1, add b times, we don't have to multiply b by x plus 1 because it already has got x plus 1 squared here, b times 2x plus 1, add c times x plus 1 squared. We choose the highest factor here, which is x plus 1. So we don't have to multiply by x plus 1. We have to just multiply by x plus 1 squared. All over x plus 1 squared times by 2x plus 1. Because the common denominator between these two is x plus 1 squared. Okay, multiplies by 2x plus 1 becomes the common denominator for all these three fractions. Now, 11x squared add 14x add 5 must be identical to a times x add 1 times by 2x add 1 plus b times 2x add 1 plus c times x plus 1 squared. Okay, so let x equal to, let's use the substitution method. Let x to be equal to minus 1. If it's minus 1, minus 1 squared is 1, 11, minus 14, which becomes minus 3, it becomes 2, equals. So this one becomes 0, this one becomes 0, 2 times minus 1 is minus 2. Minus 2 add 1 is minus 1. Minus b. Therefore, b is equals to 2. B equals to minus 2. Yeah, b equals to minus 2 because minus b is equals to 2. Therefore, b equals to minus 2. Okay, the next one could be x equals to minus a half. If it's minus half, minus a half squared is quarter. 11 times quarter is 11 over 4. Plus 14 times minus half is minus 7. Add 5. Equals, this one becomes 0, this one becomes 0. Minus a half plus 1 is half. Half squared is quarter. It becomes quarter c. Therefore, c is equal to 3. Okay. Next one, you can substitute any value for x now because there are only two roots and which we have already substituted those two roots. Let's substitute 0. If x is equal to 0, because it's valid, this is identity. So therefore it's valid for any value of x. 11 times 0 squared is 0. Plus 14 times 0 is 0. Add 5 is equal to 0 plus 1 is 1. 2 times 0 is 0 plus 1 is 1. 1 times 1 is 1, 1a. Plus 0 plus 1 is 1. It becomes 1b. Plus 1c. We know that b is minus 2 and c is 3. Therefore, 5 is equal to a minus 2 add 3. Okay. So it becomes a plus 1 is equal to 5. Therefore, a equals to 4. So, as a result, 11x squared plus 14x add 5 over x plus 1 squared times by 2x plus 1 is identical to a, which is 4 over x plus 1 minus, because b is minus 2, 2 over x plus 1 squared add c over 2x plus 1. Okay, so end of the section 1.4. So you should be able to do exercise 1e, which is page 13 from the pure 2.